From this great mantle that covers 3/4 of our planet came the first living things. On every continental shore, men have gathered to build great communities. From here has come challenge. Venture out, find new lands. Throughout our history, here was a barrier protecting us from enemies. Here as well an international right-of-way for commerce and friendships that have made us a nation and a power. Today we need more than 75 raw materials to produce our goods, to live our way, defend ourselves, and support our allies. Of these materials, all but a dozen must come in ships through corridors that we must keep free of threat. A growing threat to the 7,000 ships that pass each day between us and our friends. An unwanted visitor, legally allowed within 3 miles of our doorstep. A threat to peace, to our welfare, our security, our lives. In less than 2 centuries, man has learned to use the underwater world for war. A submarine was first used as an offensive weapon in the American Revolution. The first attack failed. The idea did not. Today's climax to man's attempts to wage war from within the sea. Polaris, able to hit any target on Earth, fired from our nuclear submarines. They can travel fast, hidden, for months on end, without surfacing. Our nuclear subs have changed the nature of war, have helped prevent war. They're still unmatched throughout the world, but they are not total defense. In other hands, a less powerful weapon than this nuclear sub poses a more immediate threat: the non-nuclear submarine. In the Soviet fleet, there are more than 400, somewhat like this U.S. craft. More than in all other navies combined. 5 times as many as we have. Conventional subs must come up periodically to get air for men and batteries. More important, they have twice the speed and 3 times the range of subs used in World War II. Even in a non-nuclear war, the Soviets would have enough conventional subs to destroy our shipping and deny us vital materials if we failed to keep the sea lanes free. Against this threat, this Goblin on our doorstep, our Navy aims the techniques of ASW, anti-submarine warfare. But to prevent an enemy from using his subs, the Navy must first overcome a greater foe, the submarine's environment, the sea. Today, in a few laboratories afloat and ashore, oceanographers gather facts about the sea. The Navy draws on their knowledge to understand better the element in which it must survive or perish. The urgent mission: probe the physics, chemistry, biology, and geology of millions of cubic miles of water. Go more deeply into a dark world as little known as the farthest space beyond the stars. From samples taken over years from all the seas, oceanographers have begun to piece together an endless puzzle. How the amount of salt varies. How temperatures vary from place to place. In samples of the sea bottom, they find clues to the evolution of Earth and all its life. This research is answering basic questions about our planet, and the answers in the Navy's hands are advancing anti-submarine warfare techniques to help us survive on this planet. Electronic soundings recreate a landscape. Underwater continents no man has seen. Valleys, plateaus, mountains. Possible future reference points for submarine navigation. Special cameras are discovering new plants and animals far below. New evidence of deep currents undetectable on the surface. The Navy directs and supports much oceanographic probing. For this is the world anti-submarine warfare men must know. The battleground where our survival may be decided. One native of this jungle is especially well studied, the porpoise, whose apparatus for sending and receiving sound is superior to that of any submarine. Within the sea, hearing is seeing. Sound is thus a basic subject in anti-submarine warfare training. In learning to know by hearing rather than by seeing, the future sonarman must first understand the behavior of underwater sound and all the factors that affect it. Sound travels 5 times faster in water than in air. It can travel hundreds of miles, usually only thousands of feet. Temperature changes alter its speed and course. So do different amounts of salt. Sediments absorb and reflect sound in many ways. Hidden mountains cause confusing echoes. All this applies to sonar, sound navigation and ranging, the Navy's chief method of detecting submarines underwater. One way of using sonar: send a burst of sound and measure its time of return as an echo from a target. The echo's character tells much about the target's nature, location, activity. Sonar can also pick up sounds the target makes. The sonarman learns how the sea can frustrate him. His chances of detecting subs are good if both his sonar equipment and the sub are operating in the same water temperature. But if the target hides in colder water, a temperature wall will deflect sonar pulses. The sonarman will have no way of knowing whether or not a sub is nearby. Besides understanding the behavior of underwater sound, the student must memorize many individual sounds. He must be able to listen beyond the sound of his own ship and another ship close by. The differences are often slight. Many sounds may be mixed together. He must know them all, especially one. Exposed to the Navy's vast store of recorded sonar echoes, the sonarman must learn to make the most subtle distinctions. Whale, sub. Whale, sub. Or an ancient target already defeated. It can reflect an echo like that of a sub. Finding even the smallest difference between echoes can be crucial. Costly weapons must not be wasted on false targets. After weeks, the sonarman understands the language better. From the sound of rain on water to echoes from fish, seaweed, or subs. The training aims at quick perception and instant response to rapidly changing situations. Then on a destroyer, the school goes to sea to meet the pressures of matching wits with a real submarine. Sea duty, a sharpening of senses and instincts. Here experience begins. To graduate the sonar student takes a destroyer, a sub, 400 Navymen. He bears a great responsibility. On what he can hear may depend our survival. Soon will come duty with a Navy task force, experience in the coordinated large-scale tactics of anti-submarine warfare. The skills of sonarmen are joined with those of many other Navymen. Together several times a year, on ship or plane, they all play a vital part in anti-submarine exercises that often begin like this. 200 miles off the New Jersey coast, a P-2H Neptune, long-range land-based ASW patrol unit. Wednesday, 09:24 hours. Suddenly a radar blip.
Bearing 09010 miles.
They head for it. Oh, 09:30. The cause of the radar echo, a submarine. Its position, heading, and speed are reported to base. Headquarters, Anti-Submarine Warfare Force, Atlantic Fleet, Norfolk, Virginia. They know the exact location of every friendly sub in the Atlantic. The new one is added. This data is now relayed to the nearest ASW task force at sea. The order: proceed and investigate. Hardcore of anti-submarine warfare, the hunter-killer task force. Heart of the force, the carrier. A fast-moving airbase, command and communication center, controlling 4 squadrons of aircraft, a squadron of destroyers, and 5,000 men, all organized and trained to detect, classify, and destroy submarines over thousands of square miles of open sea. The order received from Norfolk: proceed and investigate. The task force commander's first problem is time. An hour and 20 minutes from the moment the sub was sighted to the time his planes will arrive over the sub's estimated position.
This is engineer. Stand by to execute Operation Sweep Down.
Of 8 destroyers screening the carrier, 2 are dispatched to the contact area.
Altimeter, 29.
The carrier's ready room. The plane crews learn about the contact area 80 miles away. Cloud cover, visibility, air and water temperatures, search procedures.
On the flight deck, check the tie-downs, wheel chocks, and all loose gear aboard the deck. Stand by.
departing unit has its special, essential job. Last to go, the Douglas AD, communications link between carrier and sub-hunters at the contact area. Grumman trackers, each a deadly tracking and weapon system for fast search, detection, and kill. The carrier's Combat Information Center. All reports come here for immediate evaluation. Command decisions depend on a total up-to-the-minute picture. 10:40. Message received. The trackers are over the estimated sub position. The trackers swap data with the P2H. The original sub-contact has been lost. They must regain it. First, they try a detection device, the Sonar buoy. It lowers a hydrophone and raises an antenna. In a quiet sea, it can pick up and broadcast a target several miles away. At this moment, no target. Throughout the search, they also use magnetic detection gear, called MAD. Radar is useless against a submerged target. A sensing device in the tail boom will detect large metal objects fathoms below, a sub or a sunken wreck. Nothing yet. 11:10. Other partners join the search. Sikorsky helicopters, combining moderate aircraft speed with the ability to hover over a target area and dunk a sensitive sonar ball. Unlike a ship's sonar, the ball is free of surrounding man-made noise. But this morning, its pulses find nothing.
No echoes.
They try several areas. Still no contact. Every ASW mission demands patience, determination, more patience. Miles away, the target, a conventional American sub. For 2 hours, they've evaded the planes. What are the prospects now? Meanwhile, the trackers have widened their search. Spook. In other words, an unidentified surface contact by radar, possibly a sub.
Roger, Spook.
By the time the trackers reach the estimated contact position, no trace of a target.
Pilot radar, Spook became sinker, 5 miles.
Now the hunters concentrate on magnetic detection.
Batman! Batman!
A second and third contact classify the object below as a submerged sub and reveal its direction and approximate speed. 12 minutes later, the contact vanishes again. Sometimes they have to play this game of cat and mouse for hours, even days. The helo's time is running out. They can stay on station only half as long as trackers. A second relay from the carrier must relieve them. 13:20. The sub wants another look. Spook. And another radar fix.
5 miles.
Down.
Bogey up there. Go deep, all ahead.
Too late. Half an hour later, the destroyers are in on the contact. The third one so far. This partner is relatively slow but brings special talents, staying power, big sonar, many and varied weapons. The second relay of helos and the destroyers now hold on to the sub for 4 hours. Then their sonar echoes become confused. He's penetrated a wall of cold water. Above, they wonder. Seaweed, fish, a wall of cold water. The confusion of echoes gives him time to escape. The carrier hears that all contacts are lost. The hunt begins again. 4 hours later, the sub takes advantage of nightfall to take on the fresh air it will need to stay down during the next day.
Now, commence snorkeling. Commence snorkeling.
The task force covers a wide area. For one member, and thus for all, strategy pays off. Miles away from the searching party, the AD gets a fix and reports it to the carrier.
10, Bell 60. Radar contact bearing 210 degrees, 27 miles from original datum, over. 1275 feet, time in 20 seconds, 22 past the hour.
Lancer, Smith now control, break. Investigate contact at time 2000, bearing 240 degrees from original datum, over.
In the morning, the destroyer sonarmen are still listening to the sub below, literally forcing the breath out of him. Below, they listen to the hunters above. Thursday noon. They've held the sub continuously for more than 16 hours.
Hi, scope up.
Below, men and batteries are exhausted. $13.50. Over 28 hours after the sub was first sighted, another hunt is over. In wartime, the target would have been destroyed, but this target was assigned to test all units of the task force. He's used his skill to sharpen theirs. The destroyers need fuel. All hands need a break. But a commercial airliner 100 miles away has sighted a submarine. Again from Norfolk, the order to investigate. For hours, the search goes on.
73 with 78 and 82.
Oh, 6:30. During the night, no contact. No sonar echo, no radar image, no clue for magnetic detection. Somewhere below, the contact has disappeared. 10 hours later, all units are recalled. Now there are questions. How did the sub evade the task force? Was it a nuclear sub? If so, whose? Where was it going? Where is it now? Where will it be tomorrow? The Navy faces a growing challenge to answer such questions. Better instruments are needed for detecting and classifying both conventional and nuclear submarines. This goal is hard to reach. Weapons are improving faster. They can destroy at greater ranges and depths than in World War II. The Navy is working to develop still better tools and techniques of every kind. Tomorrow's task force may include hydrofoils that can reach a target sooner, stay with it, and kill it with a variety of weapons. Already we have the nuclear attack sub, deadly enemy of other subs. This growing undersea power is a good answer. But we must find more. We must force the sea to give up more secrets. Our oceanographic ship tonnage is only 1/8 of the Soviet tonnage. Our ships are less modern than theirs. We must do more than catch up. Today, increased research is beginning to help overcome our oceanographic handicap. Deeper exploration and understanding of the sea will bring better ways of communicating and listening underwater, better ways of pinpointing a target. Beyond our defense and our survival is greater promise. The seas of our planet hold endless wealth, food, minerals, fuel. This inner space can help provide a better life for all on Earth. But to reap this harvest, we must first make our freedom secure. If we lose control of the sea, we lose control of our destiny. For 2 centuries, a special breed of men have been going to sea to ensure that destiny. Back of them, throughout the nation, the Navy, science, and industry work to increase their capability for countering any submarine threat. Here, today, is balanced, ready strength. More than hardware, horsepower, firepower. It comes from the way each Navyman does his job, and from the way a nation shares his purpose. From such purpose comes strength.